Assalamu alaikum students. Once again we have to see the use of dimension analysis, and this time we are going to derive the relationship among the various physical quantities. So this time the relationship the use of this dimension analysis to derive relationship among various physical quantities. What you are going to understand. In order to understand it, let's illustrate an example which I have pasted here. Derive dimensionally the expression for the centripetal force acting on a particle of mass m moving with velocity v in a circle of radius r. I'm saying we're having a body which is moving in a circle, and this body is here. This is the body, this is the center, and this body is having a mass m, velocity v, and it is at a distance of r. So I have to show dimensionally a relation how the force, the centripetal force, once you whirl that very stone, you are moving that very stone tied to a rope in a circle. So there is a centripetal force, there is centrifugal force, there is centripetal force. Centripetal force maintains the circular track of that very body. It is having the body is having a mass m, where having it's having a radius r, and it's having a velocity v. The track, the radius of the track is r, and velocity of the body is v, mass is m. So we have to derive how force depends upon the radius, how it depends upon the mass, and how it varies with the velocity. Here, in order to solve this very question, this will make you understand how there is relation. So I will here say here force depends upon mass m. It depends upon velocity v of particle, and radius r of the circle in which the body is moving. So we have to derive a relationship between them. So I will say here, I will solve it like this. So write it as f directly proportional to m, as it depends upon the m, directly proportional to m, and m should have some power, m should have some dimension, and that is a. It depends upon the v, and I will put a dimension of b. It depends upon the r, and I will put a dimension of c. Listen carefully what I am doing. The question is derive dimensionally the expression for centripetal force acting on a particle, and the mass of particle is m, and that particle is moving with velocity v and in a circular track of radius r. Here what I did, I took a body of mass m, it is having a velocity v and moving in a circular track of radius r. So I will say the force actually depends upon the mass, the velocity, and radius as given in the question. So I will say force equals directly proportional to m raised power a, where a is the dimension of mass, v is the dimension of velocity, and c is the dimension of radius. So removing proportionality, which implies f equals to what? K times, where we are having constant m raised power a, v raised power b, and r raised power c. So now we do know where k is the constant. This is the dimensionless constant. A, b, and c, as I told you, these are the dimensions of mass, velocity, and radius. So now on the both sides, I will write the dimensions of different things. What is the dimension of force? We are having the dimension for force, that is m1, l1, t minus 2 equals the k is the constant, the dimension listing is placed there, or whether you are going to use it or not, because in dimensional equation constants we don't use the constants. Then it is mass, simply we will place it m, but it has a power of a. Then we are having velocity. Velocity is having a dimension of m0, l1, t minus 1, and it's having a power of b. And then we are having r, the radius, it's having m0, l1, t0, and it's having a power of c. So on both the sides, what will we do? We will equate the dimensions of same quantities. I will make a change. It is here again. It is here m1, L1 t minus 2. And on this we decide whether we use k or not. It hardly is important here. Here is m raised power a, here is m raised power b, here is m raised power c. Here is m 0 into c, that is 0, 0 into b, that is 0, but here it's, so we're having the dimension of mass, we're having simply m raised power a here. Now there is no L, there is L, there is L. So L, the length is having a dimension of base, it will be same, it will be B plus C. There is no time, there is time, there is no time. So time is having a dimension of minus B. This step is very much important, how I did it. There the mass is having a power A. There the mass is 0 into B, that is simply 0, 0 into C, that is it. So mass is having an overall dimension on the right side A. Length, there is no length, there is L raised power 1, that is simply B. It's L raised power 1, that is simply C. So bases are same, power will be added, it's L raised power B plus C. And for time, we're having only here, it will be T raised power minus 1, that's minus 1 into B, that's simply. Now what we have to do, we have to compare. Now we have to compare powers of similar quantities on both sides. We have to compare the power of similar, that's mass. We have to compare actually the powers by mean dimensions. So a equals to 1, b plus c equals to 1, minus b is equal to minus 2. So on comparing power, what we'll get, we get a equals to what, 1, b plus c equals to 1, and we're having minus b equals to minus 2. So as a is equal to 1, so we get the dimensions for the respect a equals to 1. So we got a equals to 1 now. From straightly we don't have to use anything. Now from here we will say b equals 2. Use this value here, we will get the value for c. Using this value here, what will get? So 2 plus c equals to 1, which implies c equals to what? 1 minus 2, that is simply minus 1. So we're having for C, we're having this very dimension, for B, we're having this very dimension, for A, we're having this very dimension. So if we will substitute these very values in the first equation, which was that if we substitute this very value of A, B, and C in equation this, which is F is equal to what? K times M raised power A, V raised power B, and R raised power C. We will substitute the values. What will we get? F equals K, keep the constant here, M, that's the mass raised power 1, that's the velocity, V raised to power, that is B, that's raised to power 2, and R raised to power minus 1, or we will say it is K times M V square by R. So F equals to K mv square by R. This is the expression for centripetal force, and how we derived it. We derived it dimension. You can have many more questions from your reference book. Just go through them, solve them, and if you are having any queries, then do contact me. Till then, Allah Hafiz.